Open your book to page 54. Today's lesson is on the relationship between degree and radian, measure of the angle. So if you look at figure 1, so you have a circle, and definition of 1 degree is that a circle has 360 degrees, so it divided into 360. And so if you look at the picture, it's very tiny, so that is 1 degree. So that is 1 degree right over here. Okay? So again, definition of 1 degree is you divide a circle into 360 parts, and one of the parts is 1 degree. Now, the radian, the definition of the radian is that you have a circle and you have the radius, right? So you get a string and you get a length of the radius, and then you wrap around the circle. And so it's going to be, so this length over here, that's r. Okay. So that's the definition of the radian. So the radian, the arc length is equal to the length of the radius. And so it's not quite an equilateral triangle. Okay. So this is r, and this is also r. Now notice the radius, because it's curved, right? So it's not quite 60 degrees. If it's straight, then you get equilateral triangle. But because it's not straight, it's curved, so the angle is a little bit smaller. So this is about approximately 57 degrees. Okay? So that's the definition of the radian. So again, radian is you get the length of the radius and you wrap around the circle, and whatever that the arc subtend, and that is your angle. Okay? So you can see that 1 radian without a circle is radian is about equal to 57 degrees. So you have to be careful how you write. So in other words, 1 degree is not equal to 1 radian. They are not the same. So on a test, some of you forgot to put down the little symbol and become radian. So again, they are not the same thing. Okay, so if you mean degree, you need to get a little circle. If you mean radian, then no circle. So that's very important because they are very different. Okay, just like like 1 inch and 1 mile, the label is very important, right? 1 inch and 1 mile are very different, right? So it's very important that you pay close attention to that. So many of you kind of did not do that on the test. Okay, now next thing is, let's go to the page 55. And talking about measure of the central angle. So you have a circle, and the relationship between the angle, so you have the radius over here, and so you got 3 variables, right? You have the radius, you have the central angle, and you have the arc length. So the relationship between them is S equal to R theta. Now, notice there are a lot of formulas. So again, as you get to higher math, instead of memorizing a lot of formula, it's better to understand the concept behind. That way, you don't have to memorize a lot of stuff. Okay? Because remember what we did, right? Remember, we already learned how to do this already. The best way to memorize this equation is by thinking it through. Okay? So the S is equal to 2 pi r, right? That's the entire circle, but you don't want the entire circle. You just want this part of it. So you times by the part that you want, okay? So it's the theta over, now, because this is measured in radian, 1 circle is 2 pi. Now, if it's in degree, then it will be over 360. But if it's radian, it's 2 pi. And notice the 2 pi and 2 pi cancel out. So that's where this equation came from. So this is when you're using the radian. But my suggestion is that better not to memorize this. So it's easy, just go and get the entire circle, get a 2 pi r, get a whole circle, then you times it by the fraction of the circle that you want, and that's it. That way you don't have to memorize a lot of stuff, because this is easy to understand and you can able to derive it. Now next, let's go to example 1, how to convert from one to the other. So to convert from radian to degrees and from degree to radian is very simple. Okay, so you need to understand that in a circle, so there's 2 pi radian in a circle, and in a circle there are 360 degrees. So in other words, 2 pi is the circumference around the circle, and it's 2 pi is the degree around the circle. 360 degrees is the degree around the circle. Okay, so they are equal. So therefore, from there you can see that pi equal to 180 degrees. So pi equal to 180. So in other words, pi over 180 degrees equal to 1, or 180 degrees over pi equal to 1. Okay, so this is equal to 1. So that's going to be a conversion factor. So you need to go and multiply by one of these to convert. And it's very easy to remember. So let's go over example 1 and you can see what I'm talking about. So on example 1a, it says find a degree measure of negative 1.5 radian. So normally they just swap the word rad. So when you see that means it's radian. So you're going to convert to degrees. So when you're going to convert to degree, whatever you're going to convert to, that's what you're going to put on the numerator on the top. So if you're going to convert into degrees, then you use this one. Okay, so again, whatever you're going to convert, that's the one you put on top. So if you're going to convert to degree, you use this one. If you're going to convert to radian, you use this one, right? So whatever you're going to convert to, whatever you want, that's the one you want to put on top. Okay, so you just go and multiply by, you want to convert to degree, so 180 degree over pi, right? This is equal to 1, so you times by 1, you're not changing anything, right? So get your calculator. So you go 1.5 negative times by 180 divided by pi, push equal. So you're going to get negative 85.94 degree. Okay? Because there's a label here. See the degree, so you get degree, right? And that's it. Now, what you actually have to pay attention. It says to 4 decimal degrees. So back up 4 decimal degrees. So let's go back up a little bit. So 94366. So run up to 37. Okay, and that's it. So again, very simple. Okay, now let's go to example B. It says find a radian measure of 44 degrees. So you got 44 degrees, and you want to convert to radian. So if you're going to convert to radian, you put a radian on top. Okay, and notice there's a degree over here, there's a degree, so the degree cancel out, right? See that? Everything has to match. So you got 44 times pi divided by 180 equal, and how many decimal place? 4. Okay, so it'd be 0.7679, and that's it. Okay, and again, no circle means radian. A little circle means degree. So very, very important. Again, that's very important because they are very different. Right? Okay, let's go to 1C. It says use a calculator with automatic conversion calculator to perform the conversion of power A and B. Well, that we just did that, right? Use a calculator, right? Now, without a calculator, what you need to do? Well, you do it manually, right? Which is kind of waste of time, right? Okay, so that's it. Okay, let's go to the next part. Let's go to page 57. And on the very bottom, it says angle in a standard position. The angle standard in the position is right over here. The 0 degree is start over here and you go up that way. So let's say if you're going to go 30 degrees. So you start from here, you go this way, okay, and that's your 30 degree. So standard position means you start right over here. Start from here and you go this way or you go this way. Again, so standard position start at, if you look at the clock, it's at 3 o'clock position. Okay, and next one. Another word you need to know is on page 58, coterminal. Again, we covered this before already, so this is kind of review. So coterminal. So coterminal means two angles that begin at the same place and end at the same place, but may not have the same number. So like this one, for example, you can have another possibility. So the coterminal, so you have 30 degrees, right? Then you can go around the circle one time. So you can keep going and end up right over here. So you start over here and you end over here. So coterminal, when you go around circle one time, you add 360, right? So the coterminal would be, in this case, would be 390 degrees. So to get a coterminal is very easy. If you go around circle one time, you add 360. If you go backward, you minus 360. So in this case, let's say you don't want to end up right over there. You want to go backward this way. So you can go backward this way. So in this case, you're going to end up with negative 330 degrees. Okay? Again, how do I get that? You minus 360 from here, right? So you add 360 if you're going counterclockwise. You minus 360 if you go backward, right? Go clockwise. And you can go as many times as you want. You just keep adding 360 or keep minus 360. So if you go around circle one more time, you end up with negative 690 degrees. So again, all these are coterminals because they have the same beginning and same end. Okay? Now let's go to page 60. Again, all these are review. We already did this from chapter 1 already. So if you go page 60, to find the arc length and the area of the sector. Again, we did this already, right? So let's go to example 4. You just have to test on that. So A, it says a circle of radius 4. So you have circle with radius of 4 centimeter. Find the arc length subtended by a central angle of 3.4 radian. Okay. So 3.4 radian is kind of a lot. It's about somewhere over here. Okay. If you don't know, don't care. Just draw a picture. So theta equal to 3.14. Okay. Now again, best way to do. Remember in chapter 1, there are three methods. I taught you guys 3 methods, right? But of the 3 methods, the easiest way to do is figure out the entire circle and you times by the fraction that you want, right? So you're looking for the arc length. So S equal to 2 pi r, right? That's the entire circle. But you don't want the entire circle. You just want this part of it. So you times it by the part that you want. So you want a 3.14 out of 2 pi. Now remember, now this is radian, so you have to use radian. Okay, again, first you get the entire circle, and you only times by the portion that you want. So you want 3.14 out of 2 pi. Right? 2 pi is the whole circle. So you want this part out of the whole thing, and that's what this means. So if you understand this concept, and it's very simple, okay, then you don't have to memorize a lot of equations. Okay, so now you can go and substitute in so in this case, then 2 pi can cancel out, and the radius is 4. And so get your calculator. So you got 4 times 3.14 equal, so 12.56. And don't forget, you need to write down the label, right? Centimeters, right? Again, many of you kind of forgot the label during the test, okay? So you lost half of a point. So remember that. Okay, so that's part A. Now let's go and do B. So now you get the same thing, except now the theta is equal to 10.0 degrees. Okay, so you can use the same picture, but right now you have 10 degrees. Again, it's very simple, right? Again, you get a whole circle, so 2 pi r, that's the entire circle, right? The entire circumference. But you don't want the entire circle, you just want the 10 degree, that's it. So you times it by 10 degrees out of 360 degrees. Again, you have to be consistent. Right? You just want 10 out of 360. You don't want the whole thing. So you can always get the whole thing, then you times by the fraction, the portion that you want. And after that, you put in the numbers. So radius is 4, and this can cancel out, or you can just leave it. doesn't matter. And also degree cancel out also, right? And okay, just get calculator, and you can punch in all the numbers. So 2 times pi times 4 divided by 36 equal, and so you're going to get 0.69. How many decimal do they say? Okay, it doesn't say, so let's just go and 3 decimal is enough. Okay, and that's it. Okay, now let's go to the sector of a circle. Again, you already did this as a homework in chapter 1. Okay, so let's go to example 5. So page 62, example 5. So again, you have a circle with a radius of 3. And you want to find a sector of, so you have the theta equal to, so you're looking for the area. So theta equal to 0.4732. Okay. Again, it's very simple. Okay. So area equal to pi r squared. Right. That's the area for the whole circle. Right. So area equal to pi r squared. So that's a whole circle. But you don't want a whole circle. You just want this part of it. So you times it by 0.4732 out of, now this is radian, so you have to use 2 pi. Right? So again, pi r squared, that's a whole circle, and times by the part that you want. You don't want a whole circle, you just want this part of it. So you times by the part that you want. Okay, so the pi can cancel out, and you can put in the numbers, so 3 squared times 0.4732 over 2. Again, write down the steps. It helps you to think through. So get the calculator, punching all the numbers. So 3 squared times 0.4732 divided by 2 equal, so 2.1294, and the label would be centimeter squared, right? Because over here you got centimeter times centimeter, that's where the square came from here, right? Because this is 3 centimeters square, that's where it came from. Okay, so this is example 5a. Now 5b is the same thing. So 5b, you have a theta equal to 25 degrees. So again, you do the same thing. So area equal to pi r squared. Again, always write down your formula. So that's a whole circle, but do you want a whole circle? No, right? How much of the circle do you want? 25 degrees. So you times it by 25 degrees out of 360 degrees. Again, this is you only want this part. You don't want the whole thing. So that's why you only multiply by the part that you want. Okay? And that way, again, you punch in the numbers, right? 3 squared, 25 out of 360. Notice I cancel the degree already, right? Degree and degree cancel out. That's why it's no more. Okay, so let's go and work these things out. So pi times, I'll be clear first. So pi times 9 times 25 divided by 360, push equal. So area equal to 19, what is it? Oh, 1.963. How many decimal? It didn't say. So 1.96, 1.963. Either way, this doesn't matter. Okay, and that's it. Okay, so again, it's very simple. You always, doesn't matter if you're looking for the arc length or the area of the sector, you just go and get the whole circle times by the portion that you want, and that's it. Okay, super simple. Okay. Okay, so let's go and do some practice. Okay, so 7 through 31, all these are odds. So do odds only. When I say A means, notice you have part A, B, C, D, right? Only do part A. Okay, so don't do the B, C, D. Just do part A for these problems. So whenever you see the part A, B, C, D, just do part A. Okay, and again, all these are odds, and that's it.